Today we're going to start our study of trigonometry. And trigonometry is an interesting word. It has a lot of nice root words in it that help you understand what it means. The word tri means three. The gon part means shape, and then the last part means study. So it literally means the study of three-sided shapes, otherwise known as the study of triangles. So the first kind of triangle we really focus on in trigonometry is the right angle triangle. And the purpose of this is to develop a basis to be able to build on throughout the study of this course. In trigonometry, a right triangle has a side across from it called the hypotenuse. And we sometimes, we will typically label this from geometry. You might have seen it labeled, A, B, and C. And the sides across from those angles are usually lowercase. And that's the way that we denote it. So an uppercase A is the angle, and then the lowercase a is its corresponding side. B would have a corresponding side of B, and then C would have a corresponding side of little c. And that's how you get the Pythagorean theorem, a squared plus b squared equals c squared. That's why they're lowercase, if you've ever wondered. But sometimes we use the Greek letters. I mean, this happens sometimes, is that you'll see people use alpha for A, which is this letter, and beta for B, and we do use this letter a lot called theta. And theta is typically used basically as like an X in trigonometry. So the point of the problem might be to find theta, right? And it might even be labeled B, but if you ever see a theta in a problem, the theta is typically the angle you're trying to solve for. So just keep in mind, very important, lowercase letters are sides, uppercase letters are angles. All right, so within trigonometry, there are 6 special ratios. And these special ratios, they're just simply names of the things that we're seeing up here in terms of sides in relationship to angles. So there are 3 of them that matter. There are reciprocal ones that I'll talk about here. The main 3 are sine, cosine, and tangent. And we abbreviate sine as just S-I-N. Please don't call it sin. It is still sine, even though it's abbreviated. And so what you'll say is you'll say sine of an angle. And again, an unknown angle is known as theta. And that is equal to the opposite over the hypotenuse. And we're talking about sides here. So like if I went back up here and looked at this problem where I labeled theta, and I asked, well, what is sine of B? Sine of B would be opposite B over hypotenuse C. So the sine of B is B over C. And it's just a ratio, right? So what you're doing is you're saying that the angle has a ratio of 2 sides. And if the ratio is opposite over hypotenuse, that ratio is called sine. Well, cosine also has a ratio. And cosine is abbreviated COS. Do not call it cos. It is still cosine. And cosine has the ratio of the adjacent side divided by the hypotenuse. And so what's interesting about that is sometimes students will say, well, what does adjacent mean? Adjacent means next to, all right? So let's go back up and look at that example, okay? So adjacent over hypotenuse. If I go back and look in this theta, the adjacent side here is next to it. It's A. And some students will say, well, isn't the hypotenuse next to it? But the hypotenuse is the hypotenuse. So you don't ever call the adjacent side the hypotenuse. So what would cosine of angle B be? It would be the ratio of side A to side C. All right, tangent is abbreviated tangent, okay, tan. Ironically, you can call that tan, just don't call this cos and sin. And that is the opposite side to the adjacent. And tangent is super useful because tangent does not require the hypotenuse at all. And so that is an important key. If you have no hypotenuse, you have a tangent, right? So if someone doesn't give you this value and I ask, well, what's the tangent of theta, it would be B over A, opposite over adjacent. And so those are just ratios. There's a little mnemonic device up here called SOHCAHTOA. You can see that I abbreviated it with little spacings. But if you write that at the top of your quiz when you take it, you'll remember all the ratios. So SOHCAHTOA. Cosecant is the reciprocal of sine. Please keep in mind this is a reciprocal. And it is abbreviated CSC for cosecant. And that simply means to reciprocate this. Okay, so cosecant is hypotenuse over opposite. It is not the inverse. We'll talk about that in a minute. Secant is abbreviated SEC, and that would be the reciprocal identity of cosine, so hypotenuse over adjacent. And then the last one is cotangent, which is abbreviated COT, and that is adjacent over opposite. There is no mnemonic device for the reciprocal identities, and I'll just be completely honest with you. If there were, I wouldn't memorize it. I would always just remember the SOHCAHTOA and then write them down and flip them over. That's the best way to do it. You want to minimize what you're remembering because otherwise it gets overwhelming. So if you remember SOHCAHTOA and you want to know what cosecant is, all you have to know is cosecant is the reciprocal of sine, and secant is the reciprocal of cosine, and cotangent is the reciprocal of cotangent, and then just write this one down and flip it over. So if these are not the inverses, what are the inverses in trig? Remember, reciprocal does not mean inverse. The inverses have a little inverse symbol in them. So the inverse of sine is called inverse sine. The function is called arc sine. The inverse of cosine is little inverse cosine. The function is arc cosine. Tangent is arc tangent. So what do these do? Keep in mind, this is what happens. If I take arc sine and I put sine inside of it, what happens is these two cancel, leaving me with theta. So you'll use these when you solve. And the same thing with arc cosine, right? If I do arc cosine of theta, the arc cosine and the cosine cancel. Same with the tangent, right? So keep in mind that why would I want to do that? Well, sine, cosine, and tangent, they find sides. So these things up here, these are ratios of sides with a defined angle. The purpose of these is to find sides. The purpose of arc sine, arc cosine, and arc tangent is to find angles. And I think understanding that is important because if people get confused and say, well, isn't the inverse of sine, isn't that cosecant? Cosecant is finding sides. So remember, inverse means the opposite operation. You use an angle to find a ratio of sides. The arc functions will find angles.